What if we could detect a forest fire from over 30 kilometers away, before it becomes a tragedy? At Altermundi, we're doing exactly that with SCI, our fire alert system. SCI is a distributed network of autonomous nodes that combine cameras, microcontrollers, and internet connectivity to detect smoke and fire in real time. Each node has cameras covering 360 degrees, connected to a micro PC that manages image capture and transmission. The images travel over the network to our central server, where an artificial intelligence model analyzes each photo looking for signs of smoke or fire. When it detects something, it generates an automatic alert via Telegram for both the local commune and our technical team. And this isn't just theory. From September 7th to October 6th, 2025, our node in La Rancherita detected and alerted about 6 real fire outbreaks. As far as we know, all fires that occurred in the monitored area were detected by the system. The most surprising thing was that several of these outbreaks were much farther away than we expected. The most distant one was 33 kilometers from the cameras. This made us rethink the system's actual range and understand that we can cover much larger areas with fewer nodes than we had projected. Now, let's talk about the technology behind SCI. The brain of the system is an artificial neural network, an open-source computer vision model. We started with a pre-trained model and adapted it specifically to detect smoke and fire through a process called fine-tuning. Currently, we have gone through 20 versions of our AI model. Each version represents insights and improvements. Building the training dataset was one of our biggest challenges. We started with an open-source dataset with fire images in landscapes similar to ours, but we soon discovered we needed to adapt the model to our specific conditions. The first problems appeared with false positives. The model would confuse urban lights at night with fire, or sun reflections on the lens with smoke. So we started collecting these problematic images and adding them to the dataset as negative examples. But adding only negatives created another problem. The model lost its ability to generalize. We needed more positive examples from our own region. Here's where it gets interesting. We can't start controlled fires to generate training data, it's too dangerous. So, we experimented with synthetic data, using artificial intelligence models for image generation. We generated synthetic smoke columns in our own photos and included them in the dataset, and the model processed them as if they were real cases. This notably improved the system's robustness. We also adjusted the proportion between images with fires and without fires in the dataset. Research in related fields suggests that when you reduce positive cases compared to negatives, the model learns that positives are special and minority events. This helps reduce hallucinations. The results were compelling. False positives dropped from 1,244 to just 4, while maintaining all true positives. So, SCI integrates low-cost hardware, free software, and continuous machine learning. Each alert validated by humans is fed back into the system. SCI is operational and working. We're detecting real fires, alerting in time, and continuously improving. This is just the beginning of a system that can make a real difference in protecting our forests and communities. If you want to know more about the project or collaborate, you can find us at Altermundi.